Have you ever just stopped to think about all the invisible pushes and pulls that are, well, running the show? I mean, literally everything, from a simple bike ride to how the planets orbit the sun, it's all shaped by forces we can't even see. In this explainer, we're going to pull back the curtain and take a look at these hidden forces that are in action all around us all the time.
So, let's start with a story. Picture this. It's a bright but really windy day, and two friends, Sonali and Ragini, decide to head out on a bike ride. They're all set to explore the countryside. But the second they start pedaling, they feel it, this invisible push. The wind is just fighting them every single inch of the way, turning their easy ride into a serious challenge.
And that really brings us to the big question, right? As they're pedaling up hills, struggling over these rough patches of road, and then just flying down the other side, what invisible forces are actually shaping their journey? Suddenly, their little summer bike ride is turned into a perfect, real-world physics puzzle. To even start to solve this puzzle, we've got to go back to the very basics. We need to talk about the most fundamental idea of all, a simple push and a pull. See, in science, a force is really just that, a push or a pull that happens when one object interacts with another. So when the wind is pushing against Rajini, that's a force. When her foot pushes down on the bike pedal, that's also a force. And we actually measure how strong these forces are in a unit called the Newton. So, what can a force actually do? Well, it turns out a whole lot. A force can take something that's perfectly still and get it moving. It can speed up or slow down something that's already in motion. It can totally change its direction. And, get this, it can even change an object's physical shape. And check this out. These two images show a couple of those key effects perfectly. On the left, you've got a force stretching that rubber band, literally changing its shape. And on the right, the fielder is applying a force to stop the ball in its tracks, completely changing its state of motion from moving to stopped.
Okay, so it turns out that forces can be sorted into two big categories. Let's start with the ones that kind of make sense to us right away, the forces that have to physically touch something to work.
We call these contact forces. The name says it all, right? For these forces to do anything, two objects have to physically come into contact with each other. It's pretty straightforward. Now, the most obvious example in our bike ride story is muscular force. This is the force that Sonali and Ragini are using to power their bikes. The action of their muscles creates a force that pushes down on the pedals, and that's what turns the wheels. It's a perfect example of a force that requires direct contact. But there's another really important contact force at play here: friction. Remember how the girls found it way harder to pedal on the rough parts of the road? Yeah, that was friction. Friction is this force that always pushes back against motion whenever two surfaces are touching. It's always trying to slow things down. So what's the secret behind friction? I mean, what's actually happening? Well, this slide gives us a huge clue. Even surfaces that look and feel perfectly smooth are actually covered in these microscopic bumps and grooves. So when two surfaces slide past each other, all those tiny irregularities catch and lock into one another, creating resistance. That resistance, that's the force we call friction. All right, now for our second category of forces. And this one is, a little more mysterious. These are the forces that can actually work from a distance, without any physical contact at all. We call these non-contact forces. They can push or pull on an object from way over here to way over there, acting across what looks like totally empty space. Kind of weird, right? A classic example is magnetic force. Come on, we've all felt this. When you take two magnets and feel them push each other apart or snap together without ever touching, yup, that invisible push or pull is a perfect example of a non-contact force. Another one is electrostatic force. You've definitely seen this if you've ever rubbed a balloon on your hair and then watched your hair stand up. When you rub certain things together, they build up an electrical charge, and that charged object can then pull on other things, like this ruler pulling on tiny bits of paper, all without making contact. And that brings us to the biggest one, the most powerful non-contact force in our everyday lives: gravity. This is that invisible force Sonali felt that was pulling her downhill at an amazing speed even when she wasn't pedaling at all. It's the constant, relentless force of attraction that the Earth exerts on every single thing, pulling it down toward its center. Now, talking about gravity brings up something that people get mixed up all the time, and it's so important to get it straight. We need to talk about the real difference between mass and weight. So here's the crucial difference. Mass is the amount of stuff, the matter, that an object is made of. And your mass is constant no matter where you are in the entire universe. Weight, on the other hand, is not constant. Weight is the measure of the force of gravity pulling on that mass.
And because it's a force, its value can change depending on where you are.
And this table just makes that difference totally crystal clear. Look at this. An object with a mass of 1 kilogram will always have a mass of 1 kilogram. But its weight, that's a completely different story. Here on Earth, it weighs about 10 newtons. But take it to the moon with its much weaker gravity, and it only weighs 1.6 newtons. And on massive Jupiter, it would weigh over 25 newtons. The amount of stuff is the same, but the pull of gravity, the weight, is completely different.
So just take a second, right now, wherever you are. That non-contact force of gravity is pulling you down into your seat. At the same time, the contact force of your chair is pushing right back up so you don't fall through the floor. Friction is keeping you from sliding away. See, these invisible forces, they aren't just ideas in a textbook. They are the architects of your physical reality, shaping every single moment. Once you start to see them, I promise you'll see them everywhere.